We are looking at factoring. And when we are factoring something with three terms, which is called a trinomial, we are going to be doing some multiplication and addition problems at the same time. We're going to be trying to find some magic numbers that solve this for us. Now, there's a few techniques that we could use, but we're going to use the fast one today. So we look at this problem right here, and what we are trying to do is turn this addition and subtraction problem into a multiplication problem. In order to do that, we need to find the common piece all the way across, but you'll notice there isn't anything in common. So instead, when we have three terms, we are going to look for two numbers that multiply to our end number and add to our middle number. So two numbers that multiply to 90 and add to negative 19. I'll show you why that's useful in a moment. Now, one thing to note is that only is going to work if there is nothing in front of the x squared or the n squared, whatever variable you have. If there's nothing in front of it, or just a 1 out front, this will work. Otherwise, this will not work. So make sure that there's either nothing out front or a 1 out front before you try to do this. So what I always like to do is start with the multiplying piece. We're going to find two numbers that multiply to 90. And I always just start with 1 times the number I'm looking for. And then go on to 2. And so some of you might know this in your head, or some of you might need a calculator to do the division. But you're going to have to divide 90 by 2, getting 45, to get that second number that pairs with it. The goal is to always multiply to 90. 3 times 30 will work. 3 times 30 is 90. 4 times, and you would take 90 divided by 4, and what you find is it actually doesn't work. So sometimes you got to throw out some numbers. 5 times 18 will add up to 90. 6 times divided out, you get 15 will multiply to 90. 7 is not a factor of 90, so that will not work, and neither will 8. 4 didn't work, 8's not going to work either. 9 times 10 will get up to 90. And once you start looping back on your numbers, so here I have a 10 and I'm kind of going the other direction, you can stop. So this is going to be my complete list of different ways to multiply to 90. Second, I am looking for something who is going to add to 19 or negative 19. And the reason I say or is because all of these numbers are positive. None of them are going to add to negative 19. We can make a quick little change later. So as I look through this, 1 plus 90 is 91. Way too big. 2 plus 45 is 47. Way too big. So I'm going to skip down a little bit. Let's go to the other end. 9 plus 10 is 19. It's not negative 19, but it's the right number. So now let's make our final little step to multiply both of these by a negative 1. The reason that will be okay is because negative 9 plus negative 10 does in fact equal negative 19, but negative 9 times negative 10, two negatives multiplied together, still make positive 90, which is really what the goal was. So as long as you change both of the signs on these numbers, you're really still going to multiply to the same thing. So that's why it's going to work out with the adding. Now, the final step is to use these two numbers as part of my factored answer. And I'm going to use my variable, in this case n, minus 9, because I had a negative 9 here, wrap it up in parentheses, and then n minus 10 over here, wrap it up in parentheses, and that is my final answer. If that seems like a little bit of magic to you, it probably is. But let's just show why that actually works. If you were to distribute this out and take everything in this first group times everything in the second, n times n would be n squared, n times negative 10 would be negative 10n, and then you continue on with the negative 9 to each thing. Negative 9 times n is negative 9n, negative 9 times negative 10 is positive 90. And you see that we have like terms down here, so that can be combined to negative 19n. And everything else stays the same, n squared plus 90. We would get right back to where we started. So we're essentially using this little math trick to help us unmultiply, undistribute this problem. So we are going the backwards direction of distribution when we do this little trick to get it in factored form. Let's try another example. So this one right here, x squared plus 4x minus 21. Again, we're going to multiply to negative 21 and add to 4. So when we multiply to negative 21, I do want to make sure all of these multiply to negative 21. So I start out with negative 1 times 21. Negative 2, well, negative 2 doesn't go into 21, but negative 3 does. 21 divided by 3 is 7. 4 does not work. 5 does not work. 6 does not work. And then you're back to 7. So this is actually a much shorter list than the last problem. And which of these is going to now add to 4? Negative 1 and 21 make 20. Negative 3 and 7 make 4. So I don't need to flip any signs here. If my number had been negative 4, I would have flipped the signs to be positive 3 and negative 7, but that's not the case here. So I go straight to my answer, which is x minus 3, and then x plus 7, positive 7. Again, if I were to distribute this out, you would find that it would get back to where I started. You are always welcome to check your answers that way. It's a great way to check your answer. Do a couple more if you feel like that would help you. We are going to be adding to 15 and multiplying to 50. So as we come up with our list here, multiply to 50, 1 times 50, 2 times, I think, quarters, 25. 3 does not go into 50. 4 also does not go into 50. 5 times 10. If 3 doesn't go in, 6 won't go in. 7 times 7 is 49, but not going to be a factor of 50. 8 doesn't go in, just like 4 doesn't go in. 9 doesn't work, and we're back up to 10. So this is our complete list. We're looking for numbers that add to 15. 51 for the first one, 27. There's our 15. So now we'll go straight to our answer, m plus 5, and then m plus 10. So this might have seemed a little complex at first, but you can see that as you get going, you can start to get pretty quick at doing these. Last one here, just a good example because it's a little tricky. We are multiplying to negative 72. Always make sure you include that negative. And we are going to add to negative 1. When you don't see the letter or the number in there, you want to make sure you remember that it is a 1 and keep that negative. So adding to negative 1. So negative 72. We've got negative 1 and 72. You've got negative 2. And if you divide that out, you get 36. Negative 3 and 24. Again, if you're wondering how I get these numbers so fast, you can use a calculator to divide them or use various mental math tricks that will help you do it faster. Negative 4 times 18 will work. 5 is not a factor of 72 because it doesn't end in a 0 or 5. 6, so we take in a negative 6 and we would get 12. 7 is not a factor because 7 times 10 is 70, but then it's not going to get us to 72. 8 times 9 is 72, so you got negative 8 and 9. And then we're looping back to 9, so we're going to stop there. Want to add to negative 1. These ones up on top, way too far apart. Let's start on the other end. Negative 8 plus 9 equals positive 1. No, we want negative 1, so we're close. If we were to make a quick change down here, if we flip both signs, we still will take positive 8 times negative 9 and it will multiply to negative 72. So we didn't change anything there, which is good. Positive 8 and negative 9 do add to negative 1. So now, straight to our answer, n plus 8, n minus 9. Good luck with your factoring.